Good morning, guys.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
So, as discussed in the last class, today we'll solve the same problems which we've solved in an interactive way. Okay. All of you keep ready your calculators as well as paper and pen where you can solve these problems now. Okay. Only 16 people, man. Any webinars or seminars going on parallelly? Very few people. Join on time, man. Everyone for the next class. Join on time. Okay, I've waited for a couple of minutes, man, but the things remain same. Only 23 people, man. What the reason? Was the reason? In fact, what is the reason? Why only few people out of what is the class strength? 60 people. There are only 23 today. Why? Yes, Chandan. Chandan is there. Class here itself is not there in a class. Yes, man. Shabit, Shashank. What's the reason? First of all, am I audible?
Yes,
Yes,
sir.
sir.
Audible.
Yes, sir.
Okay. What is the reason, guys? Only 23 people. Huh? Okay. Can't help. Okay, so whoever are there in the class, we should solve the problems on them. Okay, just take the serious problem. The inner surface of a plain wall brick is at 60 degrees Celsius and outer surface is at 35 degrees Celsius. Calculate the rate of heat transfer per meter square, he says. Per meter square, in the sense you can take A as 1 meter square directly. You need to substitute it. Okay. Next, calculate the rate of heat transfer per meter square of the surface of the wall. T class. Which is 220 mm thick. So that means if you take a wall like this, okay, this particular wall has a length or thickness of 220 mm. I can take this as tx or I can take this as length, whichever notations you are comfortable with, you can go with that. Okay. And what else he has given? The thermal conductivity of the brick wall he has given. So I'll just list down the given data now. So given the value of K, he has given how much it is. It is 0.51 watt per meter degree Celsius, and that is a value. What else is given? Okay. Inner surface. Inner in the sense I will consider this to be the inner. Okay. And this to be the outer surface. So for the inner surface, the wall is at 60 degrees centigrade. So here I would consider this as T1 to be 60 degrees centigrade. Okay, fine. Then the outer surface, that means the opposite wall, is at 35 degrees centigrade. So here it is 35. So I take it as T2 is equals to 35 degrees centigrade. That means the temperature drops from 60 to 35 in a linear fashion like this. That's great. What else? Is given break of the wall. What you are supposed to calculate? You are supposed to calculate what is the value of the heat transfer, which is Kev per meter square. He has asked. So Kev per meter square. That means Kev per area. Heat transferred per area is nothing but the heat flux, which is denoted by small Kev. So always do remember what is your small Kev. Small Kev talks about the heat flux that is equal to Kev, that is capital Kev divided by area. What is capital Kev? Capital Kev is amount of heat transferred amount by the area. So amount of heat transferred divided by area is nothing but your heat flux, which is indicated as just Kev here. So this is the funda of this particular problem. So how we are supposed to solve it? Yes, how we are supposed to solve this problem? So I need to calculate the value of Kev. How?
minus K A T d by dx.
Okay. So Kev is equals to minus Ka dt by dx. You can go with it, which is known as Fourier law of heat transfer. To be precise, conductive heat transfer. Okay, so this is known as the Fourier law of conductive heat transfer. I can go with this, no problem, but even you can go with the electrical analogy. Okay, what does electrical analogy says? If there is a resistance to a flow of current across certain voltage V, then how these three parameters are interrelated according to electrical principles? How these are interrelated?
V is equal to
Then
I R.
with is I and with okay, not there. Next. Yes, Shabit, you are telling something.
V is equal to IR.
So V is equals to I by R. So that is how you will analyze an electrical resistance to the flow of current. Similarly, now I have something called as thermal resistance here. Okay. So for that thing, I need the amount of heat to be transferred. V is equals to I by R. Is that right? Okay. I can even write it as I is equals to V by R, right? Fine.
Yes, sir.
So I is the flow of current, where Q is the flow of heat. So V is the potential difference across its ends. Here, there will be temperature difference across its ends. So it is T1 minus T2. So already have taken minus sign here, so no issue. Divided by resistance. So resistance in the sense it is thermal resistance. Now, which type of heat transfer it is, whether it is conductive heat transfer, convective heat transfer, radiative heat transfer. So which type of heat transfer is in this particular problem here?
Conductive.
Conductive.
Conductive. So I have to take conductive resistance, which says it is L divided by Ka. Hope I am right. Yes or no?
Yes, sir.
So first going with this particular analogy, so how will you calculate? Q is equals to T1 minus of T2 divided by R thermal. So that is R thermal first you can calculate. That is divided by L divided by Ka. What is L? L is 220 mm. So substitute in meters, so it is 10 to the power of minus 3. K value is 0.51 watt per meter degree Celsius, no need to change it. And area value, so it has asked us to calculate per meter square here. So I would assume A to be 1 meter square, so it is 1. So thereby you can calculate what is our thermal. Okay. Next, you can calculate what is Kev, T1 minus T2 divided by R thermal. So it is R thermal value will you calculate? T1 is 60 minus 35 divided by whatever value you get. So Kev value and as well as the R value I require from you guys. Okay.
0.4313.
Solve it, which R thermal
Yes, sir.
resistance. Okay,
4313.
0.4313. Calculate the amount of heat transferred.
57.90.
57.99 something watt per meter square. Now, whoever gets the value uh, of the same value, they can directly raise their hands. So there's a new feature in Google Meet. You can use that and raise your hands if you get the same value. If you don't get the value, or else it is a different value, you can switch on your mic and say, Ashwita, good. So that's good. Yes, Namita. Joel. Solve it, guys. I want everyone to solve 57.96. Okay. In the decimal points, if it is varying, then no issue. 50.7.96. Okay, fine. Good. Shabbat. Yes, what about others? What about Ashanul, Amit Sangoli, Nitin? Good. Pratish, good.
Sir,
Yes. Good, good, Ashanul. Nice. What about Numan? Got the value of Shashank? Shravan Pujari? Okay. Okay. Good. So now, got the problem, everyone? Any doubts in this? Simple, right? Everyone got the problem?
Yes, sir.
Okay, good. See, this particular question, there is we shall have a little bit of competitive thing between us now. I will just raise a question. Let's see who answers it first. Okay, let's see who answers it first. And that question is, see, what understand my question very carefully. Okay, with this particular temperature difference, that means T1 is at 60 degrees Celsius and T2 is at 35 degrees Celsius. What does it mean? This particular ball is at the temperature of 60 and this particular ball is at the temperature of 35 with the same thermal conductivity value of 0.51. With the same material, I am getting it the heat transferred to be how much? 57.99 watt per meter square. So this much amount of heat I am able to transfer within the material which this temperature limits prevailing. Okay. Now my question is, understand this question carefully. So now if I want to increase my Q value to 100 watt per meter square, if I want to increase my Q value to how much? 100 watt per meter square, then what should be the value of T1? At what temperature should I raise the first wall temperature? What should be the value of T1? So that is my question. Let's see who answers it.
60.
How come?
Wall 1, sir.
Ah, this one,
Okay.
T1. I have just highlighted it.
Okay.
Let's see. And your time starts now. Hope you got the question. If you are not clear with the question, you can ask me once again. I will do explain it once again. So initially it was 57.9 and
78.15.
around 56. How
78.15.
much?
78.15.
78.15 should be the temperature of T1 so that I can get 100.
Yes, sir.
Let us see for the answers. Answers by the others.
Okay.
78, sir.
Good. 78 Adarsh. What about others? If you got the same value, you can raise your hands, by the way, just by tapping it up. I'll come to you. Good. Method. And switch. Option also 78. Good man, Karthik. Very good. Okay, shall we go for the another one? Shall we move to the next problem? So here is the next problem. The reactor wall is how much? 320 mm thick. It is made up of an inner layer of fabric, which has a thermal conductivity value of 0.84, he says, covered with a layer of insulation. So that is covered with a layer of insulation, which has the K value to be 0.16. The reactor operates at the temperature difference of so and so. Okay, ambient is that much. Determine the thickness of the fabric. So that is here. Very good question. Okay. And calculate the heat loss pre-assuming that the insulating material has a maximum temperature of 1200 degrees Celsius. So I think we have already solved this, but once again in a clear mode. Okay, try this problem, everyone. So how to solve this? There are two layers. So first one, there is a fire brick lining like this. So this is a fire brick. After that, there is a coating of an insulation. Very good. Next, the values of K is being given, I guess. Let us take this material to be A and this material to be B. Okay, so Ka is given as how much? 0.84 watt per meter degree Celsius. Similarly, the value of Kb 0.16 watt per meters degree Celsius. So these are the values. Now I think he has asked us to calculate the lengths. So this is LA and this is LB. Okay. So here the temperature he has given as T1 is equals to 1325 and ambient this is this. So here I can take it as T3. Oh shit. Okay. Okay. T3 is equals to how much? 25 degrees Celsius. And intermediate temperature he has specified where T2 is this one, 1200 degrees Celsius. Okay. You need to solve to get the values of LA and LB. I think you must be giving the value of Q. Okay, total length is being given, I guess. So this total length is being given, which is 320 mm. So I can just write L is equals to LA plus LB, that is equals to 320 mm. Okay, so this whole thing he has given. So how to solve this problem now? How to solve this? How to solve this? Any idea? Yes? Any idea?
Solving the first block and adding this second block.
Okay. See.
Otherwise,
I'll just
T1
say,
to T
yeah.
temperature.
Okay, let me put it in this way, Rakshan. The amount of heat which is getting transferred remains same throughout. Keep this in mind. The amount of heat which is getting transferred remains same throughout the blocks. In the sense, if you calculate at this point, that is the Q at the first block, it will be same. And if you calculate at this point, the value of Q would be same. Even if you calculate at a whole stretch, the amount of Q remains same. That means whatever heat is getting transferred, so that your 1325 is dropped to 25 degrees centigrade, the overall heat transferred would be same. So in that particular sense, what I will be doing is the heat flux I am talking about. So I'll be calculating what is the heat flux in this particular block. Next, I will be calculating what is the heat flux in this particular block, and even I will be calculating what was the heat flux in the total combined block, and try to form an equation with that. So how to calculate the heat flux? Q is equals to, for the total thing now I'm taking for the total thing. So total combined, whatever you can call it as. So total or combined for this particular segment, how will you analyze the heat flux? So that is my question now. So Q is equals to, I told you it is temperature difference divided by the resistance. What it is? It is the temperature difference. So what is the temperature difference for whole the block? For the full block, what is the temperature difference? T1 minus T3? Correct? Am I right?
Sir.
Yes, sir.
So the temperature difference for the whole thing is T1 minus T3 here divided by how many resistances are there when you consider whole of this block. When you consider the whole of this block, how many resistance you can observe? You can offer the resistance with material A, and even you can offer the resistance with material B. Now, calculating it individually, RA is how much? RA is nothing but L divided by, just a minute, okay, total combined thing, T1, T3. Now, I will calculate the resistances which is offered by two segments. First, resistance which is offered by the segment 1, which is RA. Generally, it is L divided by KA, right? Now, I can write it as L of A divided by K of A into A. So A in the sense, the area of cross section, would be same for all the blocks. This particular area of cross section is even same for this particular block also here. Got it, right? So I can LA divided by KA. Similarly, when I calculate the resistance which is offered by the second block, that is the block B, it is LB divided by KB into A. So you can just neglect the things because I am calculating the heat flux directly. So it is LB divided by KB. Okay. Now, coming back to this particular thing here now. What I was doing, I was calculating the heat flux for the entire block. So that is the reason I have taken the temperature difference as T1 minus T3. Now, which resistance I should take, whether I should take RA or RB for my consideration. Here I have to put some thermal resistance, right? Here I have to put some thermal resistance. For that case, when I consider for the whole of the block with temperature differences T1 and T3, should I consider RA or should I consider RB? What should I do? Yes. What should I consider here?
Both. You should add both.
Very good. So we should add both, but since you are considering whole of the thing, here some resistance would be offering, and you come here, here also some resistance would be offering. So you need to add the both, and the right answer is RA plus RB. This is equal to. Now, when I consider the only block A, now what will be my temperature difference when I consider only this particular block here? What will be my temperature difference? What will be my temperature difference?
124.
Okay, in terms of notation, Rakshan, so it is T1 minus of T2. So when I consider this block, I would take the temperature difference between these two ends, which is T1 minus of T2. And the resistance offered is just RE. Similar, consider it for the another block, which is this. Okay. Here, the temperature difference, I can take it as T2 minus of T3 divided by resistance offered by that particular block, which is RB. Now, substituting the values of just RA, RB, and whatever it is T1 minus T3 divided by RA is LA divided by KA plus RB is LB divided by KB. So that is equals to T1 minus T2 divided by LA divided by KA. That is equals to T2 minus T3 divided by LB divided by KB. So this is the overall heat flux, which remains same. Either you calculate with respect to combined block, or if you calculate with respect to the block 1, or if you calculate with respect to the block B. So the value of heat flux throughout the surface remains the same thing. So either you can consider the first two segments, or you can equate this with this. Both yields the same answer. So just equate the first two, which is this. Just equate these two here. So it would be what? It is T1 minus T3 divided by LA divided by KA plus LB divided by KB. That is equals to T1 minus of T2 divided by LA divided by KA. So this is the substitute things wherever it is required. So it is 1325 T1 and T2 T3 value is 25 divided by length of the A. Yes, length of the A you have to find it out. So divided by K is 0.84 minus of LB you have to find it out, divided by KB is 0.16. That is equals to 1325, which
Sir,
is the value
LA
of T1.
minus or LA plus?
LA plus, man. LA plus. 1325 minus T2. How much is the value of T2? 1200. 1200 divided by LA, you have to find it out, and LB, KA is how much? 0.84. Okay. Now, either you can solve fully. At the last, you'll be getting the equation LALB is equals to some constant term, hundreds or something like that. There you can change the value of LB in terms of LA, so that you will be having only one unknown, or else initial stage itself you can change, whichever it is comfortable you can do it. So from here I can just imply it as LA is equals to how much? LA is equals to 320 minus LB. Okay, same thing I'll be using here. So it is 1325 minus 25 divided by LA divided by 0.84 plus LB is nothing but it is LA something 320 minus LB. Okay, I need the value of LB here, so it is 320 minus LA. So this should be what? I need the value of LB, it is 320 minus so it is 320 minus LA divided by 0.16, correct? 16. So that is equals to 1325 minus 1200 divided by LA divided by 0.84. If you observe this particular equation, so you have only one unknown. You can solve this with all your mathematics and you can give me the answer for LA. And even from that, you can use the this particular equation here to calculate your value of LB also. Yes, solve this problem and give me in the chat box or switching on your mic.
Is it 114.67? LA.
So LA is 114.61. I remember this value, man. It's right. And others? What is LB? It should come around 200. Because LA plus LB is around 320 something, right? So just subtract these two, you'll get the value of LB.
Two not 5.32.
205.32.
32.
Yes, guys. So if you got the sum and left, you can raise your hands, or if the values are wrong, you can just switch on your mic and speak. Meanwhile, give your attendance. Abdul Rahman, Abhinav, Adarsh, Ashanul, Ahmad Reza,
Sir, Adarsh present.
Akshay Arian,
Hassan present, sir.
Adarsh. Okay, Ashanul is there.
Hassan present, sir.
Okay, Ahmad Reza, Akshay Arkotian, Amit Yaslahari, Amrat,
Present, sir.
Ashwin K.A. Okay, Amrat is there.
Yes, sir, present.
Ashwin K.A. Yeah, Ashwin K.A. Ashvitam,
Present, sir.
Chandan C.
Present, sir.
Binoy, Fahad,
Present, sir.
Faizan, Gara, Gautam, Chapil,
Sir, Gaurav present.
M. Okay. M. Karthik,
Present, sir.
Fasil, Sihab,
Present, sir.
Asif Ali, Was, and Suraj,
Present, sir.
Nafa, Namita,
Present, sir.
Nandish, Nartan, Niharika,
Present, sir.
Nishchat.
Sriyarika present.
Yeah, okay. Nishchat, Nitin
Present,
George. Okay. Omkar, Prathan,
Present, sir. Omkar.
okay. Pratish Suvarna, Rajat
Present, sir.
Rai.
Present, sir.
Okay. Next is Dakshan K, Ramdas,
Present, sir.
Ranjat, Shapet,
Present, sir.
Saga, Shahzad Abdullah,
Present, sir.
Shashank DC,
Present, sir.
Shetty Sujay, Shetty Tejas, Shravan Kumar,
Present, sir.
Sriraj,
So, Nitin present, sir.
Nitin George. Where were you, man, when I called you? Sriraj, Saurabha, Suman, Varun, Ishwara, Amit Sangol,
Present, sir.
Yesh Markal, Prajwal Hegde,
Sir, Nilesh present.
Present, sir.
Okay. Sandesh, okay.
Present, sir.
Sachin,
Present, sir.
Yes. Rohan,
So Nilesh present.
Mark. Rachan.
Prajwal.
Yes, man, Mark.
That means
It's a word mark. Okay. Rachan, Rohan, Varun, Adarsh P, Muhammad Amin, Uman Asaddi. Okay. So, how many of you got this problem? Got the same values? You can raise your hands.
Sir, others present.
Where were you, man? When I called him.
Sir.
Okay.
No, sir, I
What?
disconnected, sir. Network issue.
Okay.
Sir, have you marked me present?
Yeah. I marked it. Don't worry, man. Once you have said, you'll be marked present. Okay. No
Thank you,
chance
sir.
that you'll be missed. Tell me
Sir,
about the
others,
problem.
sir.
Hey, Mark ಮಾಡಿದನು Adarsh P ತಾನೆ. I have marked you. Okay.
Yes, sir. Okay, sir.
ಈಗ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ಯಾ? Have you done the problem? If you have done, raise your hands. Very good.
Done, sir.
Okay, good. So hope you got these two problems. They were easy. We will solve some more complex problems. And let me just have. There is a question for you guys. Like, how many of you are preparing for national level examinations? It might be the engineering services, or it might be the GATE, or it might be any government exams where it require a lot of concepts to be written. How many of us are preparing for that? National level examinations. It might be SSC, anything. AFCAT. No one? Okay, Shanul. Good. Okay. So I thought of solving some of the problems from that segment also. Okay, fine. So we'll solve from the textbook. So we'll take some more complex problems on the heat transfer, and we shall solve in the next class. Till then, take care, be happy, keep smiling.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, excuse me, sir.
Yes.
Hello.
Yes.
Sir, for today's class, I didn't got the link, sir. Hello, sir.
Link? Yes, man. So who is
Yes,
speaking? Zavil?
yes,
Javil.
Javil, sir, Javil.
Okay.
I didn't got the link, sir. I mean, the links are deleted some mistakenly.
Okay. So if, just check your calendar, Google Calendar.
Yes, sir. The link.
All the classes has to be scheduled there. Is it scheduled or not?
Sir, only in my calendar, only Tuesday and Wednesdays are there.
Okay.
I think.
Okay, Javil, you do one thing. In the next class, just at the start of the class itself, remind me to add, just list out whichever periods, whichever classes you had missed. Suppose if Monday there is a PE class and PE class is not scheduled for you, list out those classes and give the email address. I'll just add you on. Okay?
So, yeah, Monday, Friday, and Saturday. These three are missed out, sir.
So give me a mail. Better you give me a mail so that it would be easy for me to copy and paste. Okay. Give me the days which you need to be added and give me your email address. That's enough. Okay.
Email. Now I find, sir, give email address.
Yeah. Now you give it. Okay.
It's jvilcm100@gmail.com.
No, man, you put me a mail
Okay,
to my
mail.
mail address.
Okay, sir. Okay.
Okay, pa.
Okay, sir.
Yeah.
Thank you, sir.